Hi, this class is to talk about simple linear regression, which is the content, the topic of chapter 14 in our class. And what we're doing now is we're looking at the relationship between two variables, okay? We will assess how much one variable impacts another variable. Let's take a look at one example here, then I can go back one slide. So what's the relationship between advertising in dollars, how much a company advertises, and how much the company sells? How much is the company sales? So I have two variables, and advertising tends to affect the sales. So the more you advertise, the more you expose your product to people, and maybe you convince more people to buy your product. So what's the relationship between these two variables? Okay, so this is what we're going to do in simple linear regression. We're going to use an equation to establish this relationship. That's called the simple linear regression model. And this slide is just to tell you that we're going to use it to analyze the relationship between two variables, like this one. One important thing is the terminology in this chapter. We're going to have a dependent and an independent variable. So always we're going to have a dependent and independent variable. The dependent variable is the variable that is being predicted, that is affected, that is influenced by another variable. The dependent variable is denoted by y, okay? The independent variable is denoted by x and is the variable that affects the dependent variable. So in our example here, the dependent variable is sales, because sales depends on advertising. Advertising is our independent variable. This is our x variable, okay? Because it affects the dependent variable sales, okay? And sometimes it's tricky to determine which one is the dependent and the independent variable. You have to think about the context. For example, if I increase advertising in the year number 1, then sales tend to go up. But just because I'm selling more, it doesn't mean that advertising is going up, okay? So you have always to think about the context. It's not always clear cut. Okay, so again, just to wrap up with the terminology, the dependent variable is denoted by y, and we assume that the way this variable behaves depends on how much the independent variable x behaves. So the dependent variable x is independent on other variables in the model. It doesn't mean that advertising is independent on everything else. It's just that in this relationship, this one doesn't depend on anything, okay? And we're gonna use a concept from math, which is the simple linear regression that establishes the relationship between one independent and one dependent variable. This relationship between two variables is approximated by a straight line and is given by an equation. You learned this equation in high school, okay? So I'm not going to talk about the equation right now, but just to make you think, this y-axis is a dependent variable axis, and this is independent. So as x increases, so does y, and this is the reason we plot a linear model here to establish this relationship. Let me show you some examples on Mind tab. Okay, so I'm in the Mind tab and I'll go over chapter 14, simple linear regression. I'm going to expand and I'm going to look for exploring statistics. Is expanded right now. So let's take a look at the applet that we have in this chapter to help us understand the relationship between two variables in simple linear regression. So let's wait to load. And here is one x and here's the other axis, okay? And here are different things. Let's say this is advertising and this is sales, to keep our example. Okay, so let's take a look here. In one time we advertise, we invest 20, I don't know, let's say $20,000, and the sales is 32. The precision here is not important. What is important is understand the idea. So we invest 20,000 in advertising and you sell approximately 30,000. Then another time you invest 22, 23, and then you sell almost 55. Okay. And then another time you invest 30,000 and also sell 55. Another time you invest, this is the investment in advertising, okay? Then the next time you invest 60-ish, and then you also sell 55. And then one more time you invest a lot of money, almost $100,000, and you sell 55. So you see that regardless how much you invest in advertising, the sales is always the same. So this happens to all these dots. These dots represents this relationship. So some of them, let's say you invest 75,000 and you sell almost 100,000. So if you see that it's very random. In this case, our linear regression model is flat because regardless how much you invest in advertising, the sales vary because of other things. So there's no relationship between these two variables. It doesn't matter how much you invest, the sales they're scattered. They don't very match. So let's change that. Let's make this relationship be more connected like this. So now it makes more sense. Let's take a look. I invest 20,000 and I sell 25,000. I invest 22,000 and I sell almost 40. Now I invest 30. Okay, I made 20 here, but I made more than 40 here. Now I invest 40 and I sell more than 30. I invest 40 and sell more than 50. You see that as I increase the amount that I invested, more I sell. You see, and this is the linear regression that we impose with a mathematical equation that establishes this relationship between these dots. This linear model here, this orange line, is like establishing the relationship of all these dots and the independent and the dependent variable. Okay, so we can see clearly here that as you increase the advertising, more we sell. We can also have an inverted relationship, something like that. Okay, so this is like we could say that the more we increase the, let's say, interest rate, the Fed increases the interest rate, less economic activity we have, because money becomes expensive and then companies invest less. It's more expensive for people to borrow money to buy stuff. So you see that this is an inverted relationship. The more we increase, let's assume that now this is the interest rate, the base, like the interest rate that the Fed establishes for the economy. So the more it grows, the less economic activity. This is gross domestic product. So the higher the interest rate, the less economic activity. Or this could be the increase in the gross domestic product or whatever. Okay, so sometimes we have relationships that are negative, and sometimes we have relationships that are positive. The more we do something, the more other something increases. Another example of a negative relationship is the mileage a car have, mileage of a car in the x-axis and the price of the car. Okay, so the car has very low miles, 10,000 miles. Let's say it retains 100% of the price. Let's say that this is retaining amount of the original price or something like that. As we increase the mileage, the price of the car goes down. Okay, so that's a negative relationship. So this is what we're doing in this chapter. We're going to establish these relationships and see how they are. Okay, so this is what these slides are showing: negative relationship. And we see that if we have here some additional terminology like intercept and slope, let me show you what those are. But before showing you, this is like the dots would be in this line for this relationship. So we see that is a positive relationship. If I increase advertising, sales go up. If I increase advertising, sales go up. Okay. And this is the regression equation that we are using to establish this relationship. Okay, this comes from math. This comes from high school. You had that in high school. So what we're really doing is this is a linear algebra. We have two axes, and we're trying to establish the relationship. So what we have is this variable y we are measuring. Let me show you. This is y. Sales, we know the amount of sales we sold. The x we know because we invested in the advertising. So we know x and we know y. What we don't know is B0 and B1. And you see that B1 is connected to x, and I'm going to explain them to you. And there is also a third term, which is an error. Okay, so B0 and B1 are called parameters of the model, and E is a random variable called error term. So these are the coefficients, and we're going to compute them. Our job in this chapter is to find these terms here, B0, B1, and the error term. Okay, so this is what we're going to do. I'm going to stop here and start a new video because I'm running out of my time and I don't want to make long videos. So this is the first introduction to linear regression. I'm going to stop here and start again in the next video.